Welcome to Emtron Training Part 45. In this training tutorial, we're going to be taking a look at working with a secondary boost control solenoid in our boost control routine. Now, the secondary boost control solenoids used on an external wastegate, we'll find that we have a top and a bottom port that we can control independent of each other. We're going to discuss why we want to do this and how to implement this properly in our programming within the Emtron. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at integrating a secondary boost control solenoid into our boost control tuning routine, whether we're open or closed loop type of boost, if we need more range of adjustment in our boost pressure beyond what just a single 3-port solenoid is going to allow us to control. Now, we've talked about this, again, we've talked about boost control in our previous tutorials, so we understand both an open and a closed loop method and how we're controlling specifically with an internal or an external wastegate. When we're talking about a secondary boost control solenoid for control, this is applying specifically to an external wastegate. Now, there are 4-port solenoids that control both the top and the bottom port on an external wastegate. I prefer not to work with the 4-port solenoids because they're extremely coarse in adjustment. If we're working with something like closed loop boost control, we'll find that it's very difficult to regulate and allow the duty cycle feedback to hit the target boost, because 1 or 2% duty cycle can be the difference of 3 or 5 psi of boost swings in controlling our boost. It's very coarse in adjustment. A 3-port solenoid, very consistent, will find 1 or 2% duty cycle might change the boost to half psi or 1 psi. So we have a lot greater control, a lot finer control over the boost. Now, there will be limitations to this. If we're dealing with a 3-port solenoid, we're going to be limited to how much boost we can build based on whatever the spring pressure is in the wastegate and how much pressure we can flow through that single 3-port solenoid flowing into the top port on the wastegate assembly. We'll find there will be a point where we have equilibrium pressure and we actually have the pressure start to exceed what we'll find between the combination of the pressure in the top port of the wastegate and the spring pressure combined. Let's say the spring pressure is 10 psi. Let's say what we're pumping into the top port of the wastegate through the 3-port solenoid, if it's at 100% duty cycle, is 20 psi. Add those together, we have 30 psi. Well, if our exhaust pressure starts to exceed 30 psi in our actual turbo manifold, we're going to find it's going to blow open the gate. Now it's going to start to bleed out some flow and pressure that's going through the turbine housing, spinning the turbine wheel. That's going to slow the compressor speed down and building less boost. So we're going to find a stalling point, and that's going to be what we want to overcome. We want to be able to have more flow and more pressure being generated through the turbine wheel, spinning the compressor wheel faster to get a further range of boost control. Again, this is a function, what we're limited to is a function of the spring pressure and what that 3-port itself can flow to the top port. Now, you could just go in and change to a stiffer spring in the wastegate. Let's just say you installed a 6 psi spring to start off with if you're a front-wheel drive car, rear-wheel drive car, and you want to be able to ramp the boost and have a nice control over the power and the boost as you're in lower gears where we're traction limited. Higher gears, you can throw all the boost out of it. We'll find if we go from a very low spring, 6-pound, 8-pound, 10-pound spring, that's our minimum boost. If we want to go in and control the boost very well on the low end or the lower gears, we need to have a low spring. If we simply go in and change to a stiffer spring, let's say we put a 15-pound spring to get more boost range out of adjustment. So meaning if we put, let's say a 10-pound spring with our 3-port solenoid, let's say we can only get 30 pounds of boost. We want to be at 40 or 45 pounds. Our only option, or one of the only options, is to change that spring to a 15 or a 20 psi spring. That'll give us enough boost range with the 3-port in a combination with that stiffer spring to hit 40 to 45 pounds. But the problem is going to be that we've now disrupted the low-end boost control. We essentially have no low-end boost control. We're going to be running a ton of power in the lower gears where we're traction limited, which is going to make traction even more difficult to try to control. So we're going to be in a situation where we go into wheel spin constantly. That is not going to be ideal. We want to be very specific of how we're controlling the boost, and we don't want to disrupt what we've already established with a low wastegate spring and a single boost control solenoid controlling the top port on an external wastegate. That's where we have a choice. We can either go in and work with a 4-port boost control solenoid, or we work with 2 boost control solenoids. Essentially, we're mimicking the same thing that a 4-port solenoid would do. 4 ports control both a top and a bottom port on the wastegate. we'll find we can do the same thing with 2 3 ports. Now the advantage to working with a secondary boost control solenoid or controlling the top and bottom port independently of each other is it will have much greater resolution in boost control. So on a 4-port control, we'll find that we control the top and bottom ports the same. We're going to be pushing pressure on the top port and bleeding pressure off the side port. The combination of those, the adding pressure and bleeding pressure, is going to lead to a very coarse adjustment in boost, meaning 1 or 2% duty cycle might give us, let's say, 4 or 5 psi a jump in boost. While that might sound like it's good, it's actually very difficult to control boost consistently day to day. And if you're using closed loop boost control, it makes it near impossible to get things right. If we control the top and bottom ports, so push pressure on the top, bleed from the bottom, with 2 boost control solenoids, one assigned for top port control, one assigned for side port, we can do the primary control or the... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.